So, hello, dear students. Today we are discussing about the analysis of BJT amplifier using H parameter model. So, after the establishment of the Q point, uh, that is suitable DC voltages of values of voltage and currents, alternative current or voltage are applied to a pair of input terminals of the transistor amplifier. The amplified signal appears at the pair of output terminals. Okay, this is called the output port, and there will be input port. So already we know there will be three mode of transistor operation, that is the CV, CE, and the CC. The in these two port there will be, we know the four variables. That is the you can see here, that is the pair of currents and pair of voltage. I1 is the input current and the I naught is the output current. V1 is the input voltage and the V naught is the output. So four variables. So actually the transistor, if we see, uh, also these four variables, and if we consider transistor is a black box, so we can represent the transistor like that. Okay, this picture representation. Two input variables, two output variables, and we don't know what have in the black box. Okay, so using these four variables, we'll determine the internal parameters of the transistor, H parameters of the transistors. Okay, so transistor is the current operating devices. The input voltage Vi and the output current I naught are dependent variables, and I1 and input current I1 and the output voltage V naught are the independent variables. So as this is the uh, V1 and I naught are the dependent variables, so it will be depends on the I1 and V naught, which is the independent variable. So we can be written in the equation form as a, that is the V1 we can represent like that. V1 equals to H11 I1, H12 V naught, and H21 I1 and H22 V naught. Okay, so this above equation can be written. Now, if we here V1 equals to HI I1, and that is the input resistance, and we'll determine that will be the HR V naught, and also you can write down the I naught equals to HF I1 and H naught V naught. Okay, so how we can determine these parameters of the above equation will be defined if H11, what will be H1 or HI input impedance? This will be the VI by II. When if we put in the equation 1, that is the V naught equals to 0. So V naught equals to 0 means actually output is the short circuited. So we'll get the input resistance H11 or HI when the output will be the short circuited. The same thing also you can determine the H12 or HR. What is the H12 and HR? H12 to HR is the ratio of the input voltage by the output current. That is the, you can say, reverse voltage transfer ratio. When it will happen? When the I1, if we put the 0 here. I1 put the 0 means in when the input circuit is open. Okay, input circuit is open. So actually, this is theoretically. Practically also you can determine if we do the practically in the input side is the open circuit, then we can determine the VI I know, mean input voltage and the output current ratio. We can determine this will be the actually reverse voltage transfer function. Also, the second equation I naught equals to H of I1 or H naught. Similarly, we can determine the H21 and H2. H21 is the HF. Okay, that is the I naught by I1. When I1 by I naught, when the V naught will be 0. If we put, then also you get the short circuit forward current gain with the output short circuit. The same manner H22 also the will be the output admittance. Okay, so this we can determine from the equation. Now, so based on this definition, hybrid parameters, the mathematical model for the two-port networks known as the H parameter model. Okay, that is the hybrid parameter model can be developed. Vi equals to Hi I1 or HR V naught, HF I1 or H naught V naught. So, if we so what we have in the black box, if we say this hybrid model, you can represent. Actually, this is the I1 as the input impedance, input side. So I1 HI, and this second will be the HR V naught. Okay, this is the voltage source, and this will be the HFI1. With this, we have seen the H naught is the output admittance. So this will be the parallel. So we will get the this configuration if we make the equivalent circuits of the equations. Equivalent circuit of the equation means this is the V1 voltage V1. We are getting the if we apply the KVL. KVL means Vi is the one voltage source. This is the summation of the two voltage HI1 and HRV0. So that's why we have given here the HI1 and HRV0. And second equation is the actual the KCL equation. Second equation is the KCL equation HFI1 and H0 V0. That is the one current I0 is the summation of the two current. So that's why we have given the second equation I0 is the that is the KCL. That is the leaving HFI1 and the I naught H naught. Okay, so there will be some now I will go to make to the H parameter models. Now this is the real numbers at the audio frequency, easy to measure. Okay, and also the from this obtain the transistor different static characteristics uh, curves, and the convenient to use in the circuit analysis and design. And this is a easily convertible from the configuration to others. Most of the transistors also the manufacturing to specify the H parameters model. Okay. And H parameter model for the C configuration. Let us consider the common emitter configuration shown in the figure below. The variable that is what we can consider IV, IC, VB, and VC for the common emitter. When the emitter is common, so obviously the input current will be the base current, output current will be the collector current, input voltage will be the base voltage, and the output voltage will be the collector voltage. So like that, we will get the this configuration, each parameters configuration. We can represent like the simple common emitter configuration. We can represent like that. Okay, I input current already we have told. So generally as indication emitter, so always HI, HR, HF and HO. So these parameter E will be connected. Nothing. If this is the common base configuration, then HIV, HRE, HRV, HFV and HOV. Okay, and collector then C will be connected. So like that we will get the all the modes equation for the all the modes and all the parameters for in the all modes means common emitter, common collector, and common base. So the equation obviously will be the you can say VB will be the HI plus IB and HRE BC, and IC will be the HFE IB and HOE BC. So like that we can represent the this four equation HRE, HFE and HOE. That is the same previous manner. That is very easy. Okay, so same also the three configuration we have given here for the three common base, common emitter, common collector. What is the equation? This is very easy as we have discussed the first equation. So first equation HI, yeah, that is the what will be the E. Either E will be for the common emitter will be connected, for the common base V will be connected, for the common collector this comma C will be connected. Okay. So now the main thing is that from the analysis of the transistor amplifier circuits, we'll determine the we'll actually analyze the amplifier circuit of the these circuits using the H parameter model. Okay, so this is the two-port active network of the transistors. That is the V1, Vs is the output source. That is the ZL load resistance is connected here. Okay, and IL is the load current, and I2 is the uh, we can see the output current, and I1 is the input current. The hybrid parameter model of the above network is shown in figure below. Okay. So from here, actually one by one parameters will determine that is the current gain or current amplifications, input resistance, ZI, and output resistance, and impedance, output impedance, input impedance, and the reverse voltage. Okay, so for a transistor, first one, you can see current gain AZ is defined as the ratio of the output current to the obviously IL by I1. From the previous picture, this is the output current ratio. Okay, what is the AI is the IL by I1. Now IL that is the we can represent from the circuit current. That is the I2 equals to, HF I1 as H naught V2. Okay, and V2 equals to what, IL, IJ, IL, ZL, and IL means minus I2. Here IL means, actually you can see the my IL, the relation of the IL and IZ is this is the opposite direction. So IL equal to minus I2. So that's your put here. And after substitute 2 in 1, we'll get I2. What is the value of the I2? And we'll get here I2 by I1 equals to HF by that is the if we put, so we'll get this one, and from this rearranging this equation we'll get the, after putting rearranging we'll get the this equation HF 1 plus ZL H naught, and A is AI will get what will be the minus I2 by I1 equals to minus A, only minus will be connected, and this is the opposite direction. Okay, so that is the for the common emitter, common base, common collector. We have written these parameters. You can determine it very easily. The same manners, same the input resistance. Input resistance will be in, that is the obviously from here what is the input resistance? This is the V1 by I1. This is the input resistance. So V1 by V1 already we know the previous equation, that is the V1 is the HRI1 and HRV2. Okay, that is the previously we have written HRI1 and HRV2. So if we put in the above equation, so we'll get this relations. If we rearrange it, this will be HI HR V2 by I1. So HR V2 by I1. This is the if we rearranging V2 is the minus I2 ZL. So if we put here minus I2 ZL, so AI is the minus I2 by I1 previously, and from here we'll get the Zi equals to what? Zi Hi plus HR AI I1 ZL by I1, and Zi equals to this one. So after rearranging, actually we'll get this equation. Okay, so same manners we'll get the voltage gain for that. That is the what is the voltage gain? This is the V2 by V1. Okay, so V2 by V1, we know V2 the same relation we'll take minus I2 by IL. Okay, so if we put in the I2 by IL in this equation, AI, the last equation, what we have got from here, this is the V2 equals to AI I1 ZL, that is AI I1 ZL, maybe equals to AI I1 ZL by V1. And if we rearrange same thing, so we'll get AI ZL into Z1. Okay, so output impedance will get also the same if we derive, so we'll get the output impedance also. So this is very easily output impedance and the voltage gain V2IBS. We can easily all these parameters very easily. Okay, and also the same for equation will be for the common collector and the common emitter. Okay, so now if we go to some, there are some basic characteristics of the common emitter. So current gain here is very high. The voltage gain is high for the normal values of the load resistance. So this is actually the comparison study. The input resistance RY is medium. The output resistance R0 is moderately high. Application of the common emitter also, if we say this is the three configuration, the C configuration comes capable of the providing the both voltage gain and the current gain. The output resistance R naught and the input resistance Ri are moderately high. So characteristics of the common base amplifier, and the application of the common base amplifier is not only common used for the application process, it is used for also matching a very low impedance source. It is a non-inverting amplifier with the voltage gain exceeding the unity for driving a high impedance load as a constant current source. The same thing. If you go to the discuss the characteristics of the common collector. So for low value of the RL current gain, AI is the high and almost equal to that of a C amplifier. Okay, and the voltage gain if is less than unity, and the input resistance is the highest of all the three configures. Input resistance, the output resistance is the lowest for all the three configures. And this is actually one of the comparison studies. The CC amplifier is widely used as a buffer stage between the high impedance source and the low impedance load. It's called the emitter forward. So comparison of transistor amplifier, this is the configurations we are given here. So simplified hybrid model approximately approximate analysis. If we go, so will be do here. So this is the main basic things of the H parameter hybrid model. Then using this hybrid model, actually, we can discuss about the different types of the when we go to the oscillator, multivibrator. So what will go now from this one? Actually, we go. This is very easy to suitable to draw the equivalent circuit under the consideration of the H model. Also, the difference of the that is the low frequency analysis, medium, high frequency analysis. Also to draw the electrical equivalent circuits. So this H parameter based model is very important to analyze the different types of the circuits and their performance parameters, their all the that is the parameters to require for the designing. So this is a very important thing, and this is we have concluded that this is the point of view of the circuit analysis. Very important. This H parameter model based analysis for the BJT. Okay, thank you very much.